Hello everyone, and welcome to this session on security maintenance on a Yocto project-based distribution. Most of you have probably developed the Yocto-based system. I'm wondering how many of you have maintained them, especially over a few years. In this session, I'm going to share with you some experiences and some takeaways from a year of maintaining a Yocto-based. Let's start from the beginning. What's the difference between maintenance and development? Development means adding new features. Maintenance is quite different. In maintenance, the nightmare scenario is an update, a minor bug fix, breaking the devices when updated. Maintenance means also no new features. It means only bug fixes. It means limited IPA changes. I say limited because ideally there will be no IPA changes, but in practice, upstream projects have different definitions of stability. Now, when you are releasing a maintenance release, you need to be sure that it doesn't break in the field. So it means that you need to retest either everything or the well-defined part changed. And of course, you need to retest the update, right? The maintenance effort can last for years. It can last for 1 year, 2 years, 5 years, 10 years, or maybe more depending on the product you're using. So it's better to be better prepared before you actually release it, don't you think? Now, let's talk a little bit right now about some details and specific parts of the Oniro project, because I'm going to use Oniro last year as an example in this case. So, what is Eclipse Oniro? It's an IoT distribution for products. For products, it means that it uses only the long-term support, so LTS branches of Yocto for development. There are also some additional board support layers, like for Raspberry Pi or the Seco boards. And also there are some quite unique and specific parts. Eclipse Oniro doesn't just support Linux, it also supports other operating systems like Zephyr. So we have Meta Zephyr by default. And then we are running CVEs and SPDX generation on all configurations. More about IP compliance efforts will be in the presentation tomorrow. I'm going to mostly cover the cve-check. Now, what it means that Eclipse Oniro adds and uses only LTS. It means that for the 2.0 version, we are working on the kirkstone branch, and we have transitioned from dunfell in early 2020. But with some changes. There is updated compiler, Linux 5.10 and 5.t15, Zephyr 3.1. There are other selected libraries that have changed on update. And of course, there are some specific layers for the Oniro project. It also means that at Oniro, we do not do any active work on the master or Langdale branches of the Yocto project. One thing that is important here is that if there is fix or a change that lands in those two branches and it gets backfixed to kirkstone, we do not see it until it hits kirkstone. Why is it so? Of course, that's the problem of having enough people and enough time to update and to test everything with a different branch. So we went with the decision to use one branch. Now, what is the layer layout in the Oniro project? First, they are those Yocto project and open embedded layer, like Meta OE or open embedded core. They are taken as is in the kirkstone branch. They're just pointing to the red release. No changes. If there are any, they are in the separate layers of the Oniro project with bbappends and similar. Then we have third-party layers, or the layers we take from different sources, either for boards or for certain functionality. In this case, we tend to use also the original layers and just point to the red release, but in some cases we create forks if there are too many changes for us to maintain, or that the changes are not yet ready for upstream layer. And finally, at the end, last but not least, there are the Oniro project layers. We have two main ones. Meta Oniro core, that includes all the Oniro specific parts that are not expected to be upstream somewhere else. And then we have the Meta Oniro staging that includes all the changes in the upstream layers, like in OE core or Meta OE, or different layers, that we are in the process of upstreaming, or they are expected to be upstreamed a little bit later. Now, what it brings in practice when we are updating the upstream, and some maintenance stories here. Imagine a situation when we have a bug. We see it in Oniro, but after some investigation, we figure out that is actually coming from one of the Yocto project. So, what do? We do a patch in Oniro. We test it and verify this patch is working correctly, and we put it in Meta Oniro staging so that the fix is available. Then we prepare the upstream fix and we test it with upstream. Depending on situation, it's either the fix for the master branch or the fix for kirkstone. We submit first master, then eventually master, then kirkstone. We get it accepted, we get the review and testing, and then when it hits the kirkstone branch, we wait to our moment of updating branch. We take the new kirkstone to us, we remove the fix from Meta Oniro staging, and we are having the fix from the upstream. The loop takes usually 1 to 2 weeks, but sometimes it takes way longer. Why is it so? You need to remember that in the Yocto projects, changes are merged in master first. There's a change that should be applied to master and kirkstone, for example. It will be put in master first, accepted, tested, and then it will start the cycle of review for the kirkstone review. It takes some time. There are some advantages of this. We do not end up having half-working solutions in the kirkstone branch because they have been put into master first and tested. And we are still getting builds and tests for the stable branch, but it takes time. So what we have done in Oniro to ease the update part a little bit are two things. First is testing with kirkstone nuts. That's the branch Steve is maintaining, the moving target with the things that are being considered for. And we test it to see if new regression is coming in. It is also useful in a case when we are blocked by some fix waiting in another layer or a regression that we need to fix on the Yocto project. So we cannot include an update of a layer, and we want to know if after this fix there's some other change that is blocking our integration. In fact, we have had a situation when we were waiting for one fix, and during that time there was another regression coming in. So then this cycle was very, very long. And the other solution we are using is the automating of the upstream updates. We have scripting checking the upstream layers and preparing commits with the list of upstream changes. Pretty useful. Still requires a manual review, a manual testing of the actual changes, but it's pretty. Now, there's one more example of a situation that happens during an update. Imagine the update, and then some completely unrelated test just breaks. You start looking into, and you figure out that this is because some package has been updated. And we do have a bbappend applying some kind of a different patch. Unfortunately, the version of the package has changed, and the bbappend has the direct version in its name, so it's not going to be applied on the updated one. This is called dangling bbappends that are not going to be applied to anything. And it has happened to us a few times that an regression came in because of that update that hasn't been. In the Yocto project, this is handled by feedback variable. It can be set either to generate a warning when there is a dangling bbappend or generate an error. What happens that there are some layers that are setting the variable to 0, so forcing it the message about the dangling bbappend to be a warning, but they are not only changing it for themselves, they are changing it for everything, for the whole distribution that is including the receiving layer. In our case, the solution was to force the bbappend, the variable to 0, to force it that those situations are always errors. And there's also a Yocto Project-based item about this subject. This kind of an issue doesn't happen just. It can also happen for patches. And that's something that we have seen too. Now, let's now cover the subject of CVEs. So cve-check, word build, and more similar. Why we are checking for CVE? A reminder, CVE is a common way to enumerate security issues, with an asterisk that not all security issues have CVEs, and not all CVEs are correct, but it's still very useful. Yocto Project has a way to check for pending CVEs in your build using the cve-check class, and that class uses the NVD database, one of the databases CVE. If you are not running it today, that's the day to start running. Now, the current status is that you can see the situation in various branches of Open Embedded because Steve has weekly scripts running the status and sending them to Yocto Security and Open Embedded Core. Probably if you are subscribed, you have already seen those. There's already also a scripting available, and there is a scripting-friendly JSON format that you can use for this data to do all kinds of statistics. For more information, see my presentation. Now, what does the CVE-check actually verify? It takes the version of the product, just the version, and it verifies if this product and this version has pending CVE. Nothing else, no static analysis checking, no verifying if this CVE is really a problem, just checking the version. The CVE-check allows you to verify either specific image or everything that has been done in a build. So that usually includes SDK. You can also run it in a specific way to run for all recipes of a set of layers. That happens with the word build. And that's exactly what the script of Steve is running every week. Now, what happens if you want to try CVE-check on a big set of layers? It works. And it's pretty fast to do, like typically 5 minutes. That's what. But it depends on the support of the word build of the layer you are checking. Some recipes from different layers exit on error because there are some missing dependencies or some other issues. We have fixed quite many issues like that, but there are still some pending in different. Oh, if your layer passes the word build, then there is no issue. If it doesn't, there is some work. Be able to run CVE-check on the, in this case. And there's one very specific case of CVE checking, the Linux kernel. In our case for Oniro, we have hundreds of packages, but more than 9 out of 10 reported CVEs is in the kernel, 90%. Why is it so? The story is pretty long here. To explain it shortly, the Linux kernel is a big piece of code, and it's also a frequent target for security research. That includes teaching, that includes developmental tools, and if you have been tracking news, that's exactly what happened in the case of the Minnesota University. The kind of issues such research finds is usually in some rarely used modules. That's logical if you think about it. Looking into rarely used module, more chances to bring you a bug out. And also, what I found in the Linux kernel CVEs is sometimes the resolution is not very clear. The data is missing in the CVE record, not very clear if the fix has been included. The solutions for this, Yocto Project has the CVE extra inclusions that covers some CVEs, but it just excludes them from the list to check. It requires more information about the reasons why some CVEs have been removed from the list and others not. And it requires the NVD database changes to be active. And what will be interesting is a synchronization with the Linux kernel CVEs website that provides different set of data. This data is also in JSON, so now we can synchronize between the two. That would be interesting, some work to do. And there is a need for some archaeology between the databases of different distros, NVD, mailing lists, and different sources to figure out if some of those CVEs have actually been fixed or not. Or they just do not make sense. Now, let's wrap up now. Development is quite different from maintenance. Maintenance requires stability, and that's why we need an LTS version. Where we can gain in the maintenance game is while automating chores we do. Updates and testing, for example, if you automate it, it's way easier. Post-processing of any statistics and monitoring of any metrics you may be looking into. And the CVE updates is a constant flow, so it requires constant effort. As you can see, there's a lot of work in this area, and if you are searching for some project work on, I have a lot of ideas here. Now, I'd like to thank all of you, and I'd like to thank people who have done the work I'm talking here. People like Pavel, like Andre, and quite many others. So thank you all, and that will be the time for questions.